Here are solutions to homework set number 6 for ECE 476. The goal in this one is to build a metronome using interrupts. I have a timer interrupt right now, keeping track of the beat, and edge interrupts. So as I hit the button on every edge, I decrease the period, increase the beats per minute. Or the other edge interrupt, I increase the period, decrease the beats per minute. Each button push is 10%. So that's where we're heading to on this homework set. Turn that off. The first problem is write a program that just outputs a 10 millisecond pulse every 1000 milliseconds for 60 beats per minute. Now there's a couple ways of doing that. What I could do is have a periodic input set for 1 Hertz. That will set the pin. Each time that sets, it'll set up a second timer interrupt 10 milliseconds later that clears it. I can then adjust the frequency for the interrupt that sets the pin. That's probably a more efficient way of doing it. What I chose instead was set up an interrupt for every 1 millisecond and then count. I wanted to be periodic every 1000 milliseconds. For the last 10 counts, or 10 milliseconds, I'll set a pin, clear it when I get to the end. Either way works. First one's probably more efficient. The second one, that's what I went with. The code for that, I set up the timer interrupt for 1000 Hertz, periodic every 1 millisecond, and the subroutine is called tick. The interrupt service routine is right here. It's called every millisecond counts mod n. 1000 seconds or 1 second. If I get to 0, I'll set a flag and the main routine goes beep. If I'm less than 10, for 10 milliseconds, I'll set the beeper, otherwise clear it. And what that sounds like is this. Get to Thani. Problem 1. It's just beeping. If I go to an oscilloscope, I can check the duration of the chirp. The duration is 10 milliseconds. The period is 1 second. Okay, problem 1. Problem 2. Now add edge interrupts. I want the period to increase by 1% on GP15, decrease by 1% on GP14, using edge interrupts. So that is the part that's in blue. The red part is the timer interrupt that we just talked about. The edge interrupts. I'm going to look at pins 14 and 15. Those trigger edge interrupts on the falling edge when I push the button. First one, pin 15, calls the subroutine up. I increase the period by 1%. The other one calls down. I decrease the period by 1%. So what that one does, going up to Thani, as I run it, as I hold down the button, you can see the period is getting longer. Each button push is 10%. I hit the other button, period gets shorter. Frequency goes up. Each button push is 10%. Okay, the third problem. Now put that all together with the LCD graphics. So here I'm going to import the 24 by 32 routine. It takes up a lot of memory, but it's got bigger, prettier graphics. I got space to spare in this homework problem. Same code as before, but now I'll turn on the LCD display, clear it, and then check for the flag. The flag is set every tick, every time it goes beep. If the flag is set every beep, it will print the period on the terminal on the LCD display, do beats per minute, and period. So what that looks like, problem 3. Put on the one button, period is getting longer. Other button, period gets shorter. And you can see that on the screen. So make the period longer, each button push is 10% longer. And the other button, each button push is 10% shorter. And that is homework set number 6 for ECE 476. And the thing to note is you can use interrupts. If you use interrupts, you have edge interrupts, timer interrupts. With interrupts, some coding gets pretty simple. So for example, on this one, I can set the beeping pretty easy using period as my variable that changes the period, how many milliseconds between beeps. I have an interrupt for increasing the period, decreasing the period. In fairly simple programs, what gets confusing, turn that off, is I have subroutines being called by hardware. In this case, every millisecond, the timer is called. Every button push, the edge interrupts are being called.